Welcome to the channel of science fiction. Don't forget to like and subscribe for more content. Enjoy listening. Aliens come to Earth and ask us how we made our first rockets. We talk about mathematics and, well, don't they? That's where it all began, the unraveling of everything we thought we knew about intelligence, science, and the universe itself. The day the first ship landed, if you could even call it a ship, was the day we learned how small we were. It wasn't sleek or metallic like we'd imagined. It looked organic, like a living thing that had grown into the shape of a vessel. It pulsed faintly, as if it had a heartbeat, and when they emerged, they didn't look like anything we'd prepared for in our endless sci-fi fantasies. They were tall, impossibly so, with skin that shimmered like liquid mercury and eyes that seemed to hold entire galaxies. They didn't walk. They sort of flowed, their movements defying gravity and logic. And when they spoke, it wasn't with words but with something deeper. Thoughts pressed directly into our minds like whispers in the marrow of our bones. "How did you do it?" they asked us. Not in English or any other language, but in a universal, pulse of meaning that every human present understood instantly. How did you leave your world? It took us a moment to realize what they meant. Rockets, space travel. They were asking how we'd managed to escape the gravity well of Earth, with nothing but fire and metal tubes. It was almost insulting the way they asked it, as if they couldn't believe creatures as primitive as us had figured it out. We told them about Newton and calculus, about Tsiolkovsky's rocket equation and the painstaking work of generations of scientists who'd used mathematics to unlock the secrets of the cosmos. We told them about thrust-to-weight ratios and orbital mechanics, about fuel efficiency and delta V. They listened, or at least I think they did, but when we finished, their reaction wasn't what we expected. They didn't nod in understanding, or marvel at our ingenuity. Instead, they tilted their heads in unison, their shimmering forms rippling with what I can only describe as confusion. "Math," one of them finally said, or thought, or projected into our skulls. "You use math?" "Yes," one of our scientists replied hesitantly. "Don't you?" The alien's form shifted slightly, its surface dimming as if it were processing something deeply unsettling. "No," it said after a long pause. "We do not." The room fell silent. Not because we didn't have questions, oh, we had plenty, but because none of us knew where to start. How could you not use math? Math was everything. It was the language of the universe, the foundation of physics and engineering, the very fabric of reality itself. "What do you mean you don't use math?" Someone finally blurted out, a young engineer whose voice cracked under the weight of her disbelief. The alien turned its gaze, or whatever passed for a gaze, toward her. "We do not calculate," it said simply. "We do not measure or quantify, or reduce existence to symbols on paper." "But how?" she stammered. "How do you build things? How do you understand the universe?" "We feel it," the alien replied, as if that explained everything, and maybe for them it did. But for us? For humans? It was like being told that water wasn't wet or that fire didn't burn. It didn't make sense. The aliens tried to explain, or at least I think they did, but their explanations only made things worse. They spoke of harmonics and resonance, of attuning themselves to the frequencies of existence and shaping reality through sheer will and understanding. They described their technology as an extension of themselves, grown rather than constructed, alive rather than assembled. To them, math was an abstraction, a crude attempt to approximate truths that could only be felt. To us, their methods were incomprehensible gibberish. The meeting ended in frustration on both sides. The aliens couldn't understand why we relied on something as clumsy and limiting as mathematics, and we couldn't fathom how they accomplished anything without it. But that was just the beginning. Over the weeks that followed, more ships arrived, each one stranger than the last, and more aliens came to study us, to observe our world and our ways. They were fascinated by us, though not in the way we'd hoped. They didn't marvel at our art or our culture or even our technology. They marveled at our minds, at how we could take something as chaotic and infinite as reality and distill it into equations and formulas. To them, we were freaks, anomalies in a universe where intelligence didn't require calculation or logic, but something far more instinctive and organic. At first, their fascination seemed harmless, even flattering, but then things started to change. They began testing us, not physically but mentally, probing our thoughts and pushing the limits of our understanding. They wanted to know how far math could take us, what its ultimate potential might be, and when they realized the answer, they got scared. It turns out there's a reason no other species in the galaxy uses math. It's dangerous. Math isn't just a tool, it's a weapon, a way to bend reality itself to your will with precision and control that no other form of intelligence can match. The aliens had never encountered anything like us before, beings who could manipulate the universe not through intuition or resonance, but through cold, hard logic. And when they saw what we were capable of, what we might be capable of, they decided we were too dangerous to be left unchecked. That's when the war began. They didn't declare it outright. There was no ultimatum or formal announcement of hostilities. It started subtly, ships disappearing from orbit, satellites going offline without explanation, but it escalated quickly. Within months, their true intentions became clear. They weren't here to learn from us. They were here to contain us, to stop us before we became a threat to whatever fragile balance existed out there among the stars. But here's the thing, humans don't back down. Not when our survival is on the line. They underestimated us from the start, not just our ingenuity but our resilience, our stubbornness, our refusal to go quietly into extinction. They thought math was dangerous. They hadn't seen anything yet. When they asked us to explain how rockets work, we thought it was a joke at first. Surely beings who could traverse the stars in vessels that pulsed like living hearts didn't need a crash course in Newtonian physics. But they weren't joking. Their shimmering forms leaned closer, their galaxy-filled eyes narrowing with what could only be described as curiosity or perhaps suspicion. "How do you make the fire tubes go up?" one of them asked, or rather projected into our minds. The term fire tubes wasn't theirs, of course. It was the closest approximation our brains could manage for the alien concept they were trying to convey. It was as if they were describing rockets not as machines, but as primitive artifacts, like sharpened sticks or flint tools. One of our engineers stepped forward, a grizzled veteran of NASA's Mars program named Dr. Patel. She had spent her entire career explaining complex ideas to people who didn't understand them, but this was something else entirely. "Well," she began, clearing her throat and glancing nervously at the delegation of aliens. "It all starts with Newton's third law of motion. For every action, there's an equal and opposite reaction." The aliens tilted their heads in unison, their liquid metal bodies rippling faintly. It wasn't clear if they understood, or if they even could understand, but Dr. Patel pressed on. "You see," she continued, "a rocket is essentially a pressurized chamber filled with fuel and an oxidizer. When we ignite the fuel in the combustion chamber, it burns and turns into hot gases. These gases are expelled through a nozzle at high speed, creating thrust." She paused, waiting for some sign of comprehension. There was none. "Thrust," she repeated, "is what propels the rocket upward. It's all about Newton's third law. The gas is pushed down and the rocket goes up." The aliens exchanged glances, or whatever their equivalent of glances was, and then turned back to her. "You burn things," one of them said slowly, as if testing out the words for the first time. "You ignite matter to create force." "Yes, Dr. Patel said cautiously. "And this force," another alien added, its voice, or thought, tinged with something that might have been disbelief, is sufficient to overcome the gravitational pull of your planet? Yes, Dr. Patel repeated. But it's not just about force, it's about efficiency. We calculate everything, fuel to weight ratios, specific impulse, delta V. Math again. One of the aliens interrupted, its tone almost accusatory. Yes, Dr. Patel said firmly this time. Math is how we understand the universe. It's how we solve problems and build things. The aliens recoiled slightly at her words, their forms rippling like disturbed water. For a moment it seemed as if they might leave, might simply give up on trying to understand creatures so fundamentally different from themselves. But then one of them stepped forward. Show us, it said, and so we did. We took them to a launch site, a sprawling complex in the middle of nowhere where rockets were born and sent screaming into the heavens. The aliens watched in silence as technicians prepared a test launch, their shimmering bodies reflecting every flicker of movement around them. When the countdown began, 10 seconds to ignition, they seemed almost nervous, their forms pulsating erratically. And when the rocket finally roared to life and leapt into the sky on a column of fire and smoke, they flinched as if struck by an invisible force. It works, one of them murmured after a long silence. Of course it works, Dr. Patel snapped, her patience wearing thin. We've been doing this for decades. The alien turned toward her, its galaxy-filled eyes narrowing once more. But why does it work? It asked softly. Dr. Patel blinked. Because that's how physics works. The alien tilted its head again. Your physics, it said slowly. Not ours. And that was when we realized just how deep the divide between us truly was. For them, reality wasn't something to be measured or quantified. It was something to be felt. Their ships didn't fly because of thrust or momentum. They flew because their creators willed them to fly, because they resonated with the frequencies of existence in ways we couldn't begin to comprehend. To them, our reliance on math and physics wasn't just strange. It was dangerous, a crude attempt to impose order on a universe that thrived on chaos and harmony. But here's the thing. Humans don't thrive on chaos or harmony. We thrive on control, on bending reality to our will through sheer force of intellect and determination. And that's what scared them most of all. They saw in us a species that refused to accept limits, a species that would stop at nothing to understand and conquer the universe around us. They saw in our rockets not just machines, but symbols of defiance. Proof that we were willing to burn everything we had just to reach for something greater. And so they decided we had to be stopped. But by then, it was too late. Because while they had been studying us, trying to understand how creatures as primitive as us could achieve so much, we had been studying them too. And what we learned changed everything. Their ships might have been faster than ours, their technology might have been more advanced. But there was one thing they didn't have, one thing they couldn't even comprehend. Math. It wasn't just a tool or a language. It was our greatest weapon, a way to see and shape the universe that no other species could match. And when the war finally came, when their ships darkened our skies and their weapons tore through our cities, it wasn't brute force or blind luck that saved us. It was math. We calculated trajectories and optimized defenses. We developed new weapons and strategies faster than they could adapt. We turned every equation into an act of defiance, every formula into a declaration that humanity would not go quietly into extinction. In the end, it wasn't our rockets or our bombs that won the war, it was our minds. The same minds that had once looked up at the stars and dreamed of reaching them no matter what stood in our way. And when the last alien ship fled Earth's orbit, its shimmering form dimmed by defeat, we knew we had done more than just survive. We had proven that sometimes being different isn't a weakness, it's a strength. Aliens don't use math. Well, maybe they should have. When the aliens asked us about our other vehicles, their curiosity seemed almost childlike, though there was an undercurrent of something deeper, something more calculated. They had been mesmerized by the rocket launch, by our ability to harness fire and physics to claw our way into the heavens. Now they wanted to know what else we had built to traverse the void. Dr. Patel, still riding the adrenaline high of explaining rockets to beings who could cross galaxies without them, stepped forward again. "We've built many kinds of vehicles for space exploration," she began, her voice steady despite the surreal audience before her. Each one tailored to specific challenges. The aliens leaned in closer, their shimmering forms rippling with what we had come to recognize as anticipation. "Let's start with rovers," Dr. Patel said. She gestured toward a nearby screen, which flickered to life with images of Mars' red surface. "This is Curiosity," she explained, pointing to a photo of the six-wheeled machine perched on a rocky Martian ridge. "It's a rover, a robotic vehicle designed to explore planetary surfaces." The aliens tilted their heads in unison. "Rovers are equipped with tools for scientific analysis," Dr. Patel continued. "Cameras, spectrometers, drills, they're essentially mobile laboratories. Curiosity, for example, has been studying Mars's geology and searching for signs of ancient life since 2012. "How does it move?" one alien asked, its voice or thought tinged with genuine wonder. "Electric motors," Dr. Patel replied. "Powered by a radioisotope thermoelectric generator, a device that converts heat from decaying plutonium into electricity." The aliens recoiled slightly at the mention of plutonium. "You use decay?" one of them murmured, its tone almost reverent. "Yes," Dr. Patel said, her brow furrowing. "It's a reliable energy source for long-term missions in environments where solar power isn't feasible." The aliens exchanged glances, or whatever their equivalent was, and then turned back to her. "Show us another," one of them said. Dr. Patel nodded and brought up an image of the space shuttle, its iconic silhouette framed against the deep blue curve of Earth. "This," she said proudly, "is the space shuttle, a reusable spacecraft that revolutionized human spaceflight." She explained how the shuttle launched like a rocket but landed like a plane, how its large cargo bay allowed it to carry satellites, scientific instruments, and even components for the International Space Station. "It was versatile," she said, her voice tinged with nostalgia. "It helped us build the ISS, repair the Hubble Space Telescope, and conduct countless experiments in microgravity." The aliens seemed particularly intrigued by the concept of reusability. "You use it more than once?" one of them asked. "Yes," Dr. Patel replied. "Reusability reduces costs and increases efficiency." The alien's form rippled faintly, as if processing this information on some deeper level. "Efficient," it murmured. Dr. Patel moved on to other vehicles. Landers like Viking and Phoenix, which touched down on alien worlds to study their atmospheres and soils. Orbiters like Cassini and Juno, which circled distant planets to gather data on their compositions and magnetic fields. And probes like Voyager 1 and New Horizons, which adventured beyond our solar system into interstellar space. "We've even built vehicles for environments where traditional designs wouldn't work," she added, bringing up an image of NASA's Ingenuity helicopter hovering above Mars' surface. "This is Ingenuity, a small helicopter that proved powered flight is possible on other planets." The aliens leaned closer still, their galaxy-filled eyes narrowing as they studied the tiny craft. "It uses counter-rotating blades to generate lift in Mars' thin atmosphere," Dr. Patel explained. "It's small but groundbreaking, a proof of concept for future aerial exploration. And yet you rely on machines," one alien said softly after a long pause. Dr. Patel hesitated before answering. "Yes," she said finally. "Machines allow us to go where we can't, into environments too hostile for human life. But why not grow them?" Another alien asked. Grow them? Dr. Patel repeated, confused. Yes, the alien said simply, as if it were obvious. Why not attune yourselves to your creations? Shape them from yourselves? Dr. Patel opened her mouth to reply, but found she had no words. The divide between us yawned wider with every question they asked. The aliens seemed to sense her discomfort and shifted their attention elsewhere, to images of lunar rovers trundling across the moon's surface during Apollo missions, to concept designs for modular vehicles like NASA's Space Exploration Vehicle, SEV, which could traverse planetary surfaces or serve as free-flying platforms in space, to towering rockets like Saturn V and SpaceX's Starship. Each new image elicited ripples of fascination from our visitors, but also something else: unease. You build so much, one alien observed after a while. Yes, Dr. Patel said cautiously, and yet you are so fragile, it added softly. The words hung in the air like a challenge, or perhaps a warning. We build because we're fragile, Dr. Patel replied after a moment's thought. Because we can't survive on willpower alone. The alien tilted its head again, but said nothing more. As the presentation continued, delving into everything from space capsules like Orion to massive structures like the ISS, it became clear that their interest wasn't just academic. They weren't just curious about what we had built. They were trying to understand why we had built it, to grasp what drove us to reach beyond our world despite our limitations. And though they never said it outright, I think they were beginning to realize that our fragility wasn't a weakness. It was our greatest strength. Because where they saw chaos and harmony as ends in themselves, we saw them as challenges to be overcome, as problems waiting for solutions that only we could devise, and that terrified them more than anything else we had shown them so far. They didn't say it outright. Not yet. But I could see it in their rippling forms and hear it in their hesitant questions. They were starting to wonder if they had made a mistake by coming here at all. And deep down, I think we were starting to wonder too. When the aliens realized that all of our technology, every rocket, every rover, every satellite, was born from mathematical reasoning, their fascination deepened into something more profound. They weren't just curious anymore. They were awed. For beings who had never used numbers to navigate their existence, the idea that we had built an entire civilization on the back of equations and algorithms was nothing short of revolutionary. You mean? One of them said slowly, its shimmering form rippling with what we could only interpret as disbelief. Everything you create comes from this? Yes, Doctor, Patel replied, her voice steady but tinged with pride. Mathematics is the foundation of all our technology. It's how we understand the universe and how we shape it to our needs. The aliens exchanged glances, or whatever their equivalent was, and then turned back to her. Explain, one of them said simply. Dr. Patel hesitated for a moment, unsure where to begin. How do you explain something so fundamental, so intrinsic to human progress, to beings who had never even conceived of it? Well, she began cautiously, math is a way of describing patterns and relationships in the world around us. It allows us to quantify things, to predict outcomes, and to solve problems. She gestured toward a nearby screen, which flickered to life with images of mathematical equations and diagrams. Take calculus, for example, she said. It's a branch of mathematics that deals with change, how things move and grow over time. We use it to calculate everything from the trajectory of a rocket to the flow of electricity through a circuit. The aliens tilted their heads in unison, their galaxy-filled eyes narrowing as they studied the equations on the screen. And then there's algebra, Dr. Patel continued. It's about finding unknowns, solving for variables and equations that represent real-world problems. It's how we design structures that can withstand earthquakes or optimize supply chains for efficiency. She paused, glancing at her audience to gauge their reaction. They seemed intrigued. "But math isn't just about solving practical problems," she added quickly. "It's also about exploring abstract concepts, ideas that might not have any immediate application, but that expand our understanding of what's possible." She brought up an image of a Mandelbrot set, a fractal pattern generated by iterating a simple mathematical formula. The aliens leaned closer, their forms rippling with what could only be described as wonder. "This," Dr. Patel said softly, "is beauty created by math." The aliens stared at the swirling patterns for a long moment before one of them spoke. "And you use this reasoning," it said slowly, "to create your machines?" "Yes," Dr. Patel replied firmly. "Every piece of technology we've ever built, from the simplest wheel to the most advanced spacecraft, started as an idea expressed through math." She began listing examples: how geometry had allowed ancient engineers to build pyramids and aqueducts, how trigonometry had enabled sailors to navigate by the stars, how binary logic had formed the basis for modern computers. "Even artificial intelligence," she added, bringing up an image of a neural network diagram, "is built on mathematical principles. Algorithms like these allow machines to learn from data and make decisions." The aliens recoiled slightly at the sight of the diagram, their forms dimming as if in discomfort. "You teach machines to think?" one of them asked hesitantly. "Not exactly," Dr. Patel said quickly. "We teach them to process information, to recognize patterns, and make predictions based on probabilities." The alien tilted its head again but said nothing more. As Dr. Patel continued her explanation, delving into topics like cryptography, which uses complex algorithms to secure digital communications, optimization techniques, which help us design more efficient systems, and statistical modeling, which allows us to predict everything from weather patterns to stock market trends, it became clear that their interest wasn't just academic. They were trying to understand something deeper, something fundamental about who we were as a species. "You see," Dr. Patel concluded after nearly an hour of explanations, "math isn't just a tool for us. It's a way of thinking, a way of seeing the world." The aliens were silent for a long moment after she finished speaking. Their forms shimmered faintly, as if caught between two states of being. Finally, one of them spoke. "You are unique," it said softly. Dr. Patel blinked in surprise. "What do you mean?" "In all our travels," the alien replied, its voice or thought tinged with something that might have been awe or fear, or both. "We have never encountered beings who think as you do, who create as you do." It stepped closer, its galaxy-filled eyes locking onto hers. "You bend reality itself," it said quietly. "You impose order on chaos, not through resonance or harmony, but through will and reason." Dr. Patel swallowed hard, but held its gaze. "That's what makes us human," she said simply. The alien tilted its head again, but didn't reply. Instead, it turned back toward its companions and began communicating with them in rapid pulses of light and sound that we couldn't comprehend. Whatever they were discussing seemed urgent and unsettling. When they finally turned back toward us, their forms had dimmed noticeably. "We must consider this further," one of them said after a long pause, and without another word or thought, they left. As their ship ascended into the sky on waves of shimmering light, I couldn't shake the feeling that something had shifted, that we had crossed some invisible threshold in our relationship with these beings. For better or worse, they now understood what made us different, and perhaps even dangerous. And deep down, I think we understood it too. When the aliens asked to take some of our mathematical books, it wasn't with the casual curiosity they had shown earlier. This time, there was a weight to their request, a solemnity that hinted at something deeper. They didn't just want to understand us anymore. They wanted to study us, to dissect the very foundation of what made us human. Dr. Patel hesitated for a moment before nodding. "Of course," she said, gesturing toward a shelf lined with some of the most influential works in mathematics. "Take whatever you need." The aliens moved closer, their shimmering forms rippling faintly as they examined the books. Their movements were slow and deliberate, as if they were handling something sacred or dangerous. They selected a wide range of texts, from Euclid's Elements to Newton's Principia Mathematica, from Hardy's A Course of Pure Mathematics to Spivak's Calculus. They took books on algebra and geometry, trigonometry and calculus, number theory and topology. They even took more modern works like Shannon's A Mathematical Theory of Communication and Knuth's The Art of Computer Programming. One alien paused in front of a particularly dense tome, Rudden's Principles of Mathematical Analysis. It tilted its head as if trying to comprehend the rows of symbols on the cover before carefully adding it to the growing pile. "You will find these useful?" Dr. Patel asked cautiously. The alien turned toward her, its galaxy-filled eyes narrowing slightly. "We do not know," it admitted. "But we must try." And with that, they gathered the books and left. Weeks passed without any further contact. The aliens had taken their books and vanished into the void, leaving humanity to wonder what they were doing, and why. Speculation ran rampant. Some believed they were trying to adapt our methods to their own technology, to combine their intuitive understanding of reality with our mathematical precision. Others feared they were studying us for more sinister purposes, to find weaknesses in our logic, to turn our greatest strength against us. But whatever their intentions were, we didn't have long to wait. One day, without warning, their ships returned, not just one or two, but dozens of them, filling the skies like a storm of living light. This time there was no pretense of curiosity or diplomacy. They came with purpose and with weapons. The first strike was surgical. Satellites went offline in an instant, their systems fried by pulses of energy we couldn't detect or counter. Then came the ground attacks, cities leveled by beams of light that seemed to unmake matter itself. It was chaos. Our defenses were useless against their technology. Our weapons couldn't even scratch their ships. It seemed as though humanity's end had come, not through war or plague or environmental collapse, but through beings who saw us as an anomaly too dangerous to exist. But then something unexpected happened. As the aliens pressed their attack, something in their strategy began to falter. Their strikes became less precise, their movements more erratic. It was as if they were struggling against something unseen, something they didn't fully understand, and that's when we realized they had tried to use math. In their desperation to neutralize us, the aliens had attempted to incorporate mathematical reasoning into their methods, but they had underestimated its complexity. They thought it was just another tool, another way to manipulate reality. But math wasn't just a tool for us. It was part of who we were. They didn't understand its subtleties, the way equations could branch into infinite possibilities, the way logic could twist and fold back on itself like a Mobius strip. They didn't grasp the beauty of paradoxes or the power of abstraction. And in trying to wield it without truly understanding it, they had created chaos within their own systems. Their ships began malfunctioning, engines sputtering out mid-flight, weapons firing unpredictably. Some even turned on each other, as if caught in feedback loops they couldn't escape. It was our chance, and we took it. Using what little technology we had left, we launched a coordinated counterattack, not with brute force but with precision, strikes calculated down to the millisecond. We exploited every weakness in their defenses, every flaw in their hastily implemented algorithms. We fought them not with firepower, but with math, with trajectories and probabilities, with optimization, Models and game theory. We turned every equation into a weapon, every formula into a strategy. And slowly but surely, we began to turn the tide. When the last alien ship fled Earth's orbit, its shimmering form dimmed by defeat, we knew we had won more than just a battle. We had proven something fundamental about ourselves. Math wasn't just a language or a tool. It was an extension of who we were, a reflection of our ability to see beyond chaos and impose order on the universe around us. It was what made us human and what made us unstoppable. As we rebuilt our world from the ashes of war, there was talk of what might come next, of whether the aliens would return or whether others like them might one day come seeking answers of their own. But whatever lay ahead, one thing was certain: humanity would be ready. Because now we knew that our greatest strength wasn't in our machines or our weapons. It was in our minds. And no matter how vast or advanced the universe might be, there would always be one thing that set us apart. We use math, and we use it well.